All right, so we're going to talk about a couple more properties of definite integrals. Yesterday we talked about how we can add them. Let's talk about if you're asked to find the definite integral with a coefficient. So the definite integral with the coefficient in front is the same thing as if you were to evaluate the definite integral and then multiply by the coefficient. And then also, if you are finding the definite integral of the sum of two functions, or the difference, it doesn't make a difference, you can separate it. So you can find the definite integral of one function from a to b, and then you can add or subtract the definite integral of the other function from a to b as well. All right, so let's check out this question. So we're going to evaluate this function, this integral from 1 to 3 of negative x squared plus 4x plus 3 dx. And then I gave you more integrals using the fact that 1 to 3 of x squared dx is 26 over 3, 1 to 3 of x dx is 4, and 1 to 3 of dx is 2. So that's really, if it's written like this, you could put a 1 there. All right, so if I separate the integral here into separate integrals, I can integrate from 1 to 3 of negative x squared dx. I can then add, using the property from before, because remember, you can add each piece, from 1 to 3 of 4x dx. So I'm just separating it into these three pieces, plus 1 to 3 of 3 dx. Okay, so now my goal is to write each one of these individual integrals as one of the three given ones. So if I write this as the negative in front, if I pull out the negative in front, I have negative, and then I have x squared dx. I know that's 26 over 3. All right, next one. If I want to try to rewrite this one as x dx, if I pull the 4 out in front of the integral, I have x dx. And then here, if I pull out the 3 in front of the integral, I have 1 dx, which is this integral. All right, so now let's evaluate this. Okay, so let's just recap what we had. We had negative x squared plus 4x plus 3. We took that and factored out the negative to get the x squared, because I want to rewrite each one of those pieces of the function to look like one of the function pieces they gave me. I factored out the 4. I took the 4 in front. So now this one looks exactly like this one. And here I took out the 3, and so now this one looks exactly like this one. All right, so now I can use what they gave me. This piece here is 26 over 3. And then I just pull the negative down. This piece here is 4. And that 4 just comes down. And then this piece here is 2. And then I just bring down the 3. So I have 26, or negative 26, over 3 plus 16 plus 6. All right, let's put that in there because I'm running out of room. So it's 4 times 4 is 16. And 3 times 2 is 6. And now I can add them. All right, so if I add them all, I need a common denominator. So this has a 3, which means this needs a 3, top and bottom. This needs a 3, top and bottom. And then if I add these all up, I get 40 over 3. So my final answer to the whole entire integral is 40 over 3. All right, let's try another one. All right, so let's check out another one. So I gave you some definite integrals. So from 2 to 4 of x to the third dx is 60. From 2 to 4 of x dx is 6. And from 2 to 4 of dx is equal to 1. Now, 2, I'm sorry. Now remember, if there's no number here, that's really 1 dx. All right, and we want to now find the definite integral from 2 to 4 of negative x to the third minus 2x plus 3. Check out all of the integrals. All of the pieces are the same, so I can use all my properties. So I'm going to try to rewrite this piece as just x to the third. So to do that, I'm going to pull out the negative in front. Okay. Here, I want to rewrite this one as just x. So to rewrite this one as just x, I'm going to pull out the negative 2 in front. These all should have dx's after them. Let me fix that. Okay. And then to write this one as 1, I'm going to pull out the 3 in front. And now each one of these guys looks like one of the integrals, the definite integrals that they gave me. So now I can evaluate. X to the third dx, the integral from 2 to 4 is equal to 60. So this is 60. And then the negative comes down in front. And then 2 to 4 of x dx, 2 to 4 of x dx is 6. And then I pull the minus 2 in front. And then 2 to 4 of 1 dx is 2. And then I pull the 3 in front. And then I just have negative 60 minus 12 plus 6. So my definite integral, my answer up here to the entire thing, because I have to add all these up, is negative 66. That is my answer using the integrals that they gave me, the definite integrals they gave me. All right, and then lastly, the question could look a little bit different in that they're not actually giving you the function itself. They're just giving you definite integrals of a function. And they'll ask you to find or evaluate different integrals. So check this out. So if I say, here's the information you're given, now evaluate from 0 to 7 of f of x dx. So from 0 to 5 of f of x dx is 10. And then from 5 to 7, f of x dx is 3. Notice that those intervals do not overlap each other. But the integral here is containing from 0 to 7, which means it's containing both of these intervals together. So in order to find f of x dx from 0 to 7, you take it from 0 to 5, which is 10. And then you add from 5 to 7, you get 3. So that definite integral is 13. And then we could just ask you a bunch of questions like that. Now, let's just recall a property or two properties from yesterday. Actually, I'm not teaching you guys every day, so it was Monday, I guess. Remember that if they ask you for the definite integral of a function and the numbers are swapped, so see how this was 5 to 7, but this is 7 to 5. Because 5 to 7 is 3, 7 to 5 is negative 3. So that was one of the properties from Monday. And then one of the other properties from Monday was if the bottom number and the top number are the same. So if it said the definite integral from 5 to 5 of f of x dx, I'm not even going to use this information here because if the bottom number, the top number are the same, then the definite integral is 0. All right, so we're going to try a few of those for homework. Some of them are going to be super easy and quick, and some of them are going to be a little bit harder. So take your time, rewatch the video, and then inbox me if you have any questions. I can help you out through Teams.